All right, so now we have another trinomial. Let's go ahead and factor this. So what's the first thing that we look for when we factor? So you are going to always have to look for the greatest common monomial. What's the second thing you look for? Difference of squares. What's the third thing that we look for? Square binomial. What's the fourth thing that we look for? Binomial pair. Okay. So is there a greatest common monomial here? No. Is this a difference of squares? No, because it's a trinomial. Is this a square binomial? No, it isn't, because 2 times a times b does not work out in this case. So we need to find a pair of factors. So right now, I would like you to figure out what this factors to finding a pair of factors. And I'll tell you right now that it is not prime, so you don't have to worry about this. This can be factored. So what does this factor to? Bridget?
Opening parentheses, x squared minus 1x, closing parentheses, opening parentheses, x squared minus 4x, closing parentheses.
So we have x squared minus 1 times x squared minus 4. And we know that if negative 1 plus negative 4 is negative 5, so we know that checks out really nicely, right? Okay, so we have successfully factored this polynomial. Let's go through our checklist one more time just in case. You can probably figure out, since we're doing this just in case, that we have something. So do we have any greatest common monomials inside either of these parentheses? No. Do we have a difference of squares? Oh my goodness, yes. Is x squared minus 1 a difference of squares? It is, isn't it? So what does x squared minus 1 factor to as a difference of squares? Yes, you actually have to remember what we've done in the past here, folks. So for a difference of squares, are you going to have one binomial that is squared, or are you going to have 2 different binomials? Ayla is mouthing the 2 different binomials, and she would be right. Okay. So what else do we know about differences of squares when we factor them? What can you say about the signs inside the parentheses for a difference of squares? Rose? Right, one has an addition sign, one has a subtraction sign. Okay, so what do we know about the first term for both of the binomials? It's x, because x times x is x squared. 1 is a perfect square. What times what is 1? 1. Okay, so we factored that difference of squares beautifully. Is this a difference of squares? Is x squared minus 4 a difference of squares? Well, let's ask. Is it a binomial? Check. Is it a subtraction problem? In other words, is it a difference? Oh my goodness, it is. And for the trifecta, are both terms perfect squares? Yeah, x squared is a perfect square, 4 is a perfect square. So what can I write down for my answer right away, just because I know difference of squares will always look like this when they're factored? Ayla? We'll have a negative and a positive sign. What else are we going to have? How many pairs of parentheses? 2 pairs of parentheses. So I can go ahead and write this immediately when I have a difference of squares, because I know that's going to be there for a difference of squares. What's the first term? X. What's our second term? And now, since we don't have any squareds, we know we can't factor it any further. So we are done. So this is the final answer for this problem here.